Do you know what are the different operations that can be performed between time domain signals and frequency domain signal? Then this is the video for you guys. So here what we'll be going to discuss is that, so how all are a continuous time signal can be converted to a continuous angular frequency or linear frequency, or a discrete time signal can be converted into a continuous time angular frequency or a discrete time angular frequency. So how we are going to convert that, and what are the back-end mathematical tools that are there to perform these things? So let's discuss those things. So this is one a very important thing, guys. So in entire signal systems, we are going to study this only. So I'm going to give you some glance of idea. So here, if you see, so we know that this is continuous time signal. So because this is x of t. So and we know this is equal to continuous frequency signal. Continuous frequency domain signal. Okay, so these are all sometime. So you guys can pause the video and try to answer the same for rest of the things like 2 3 4 the other operations also. Please write whether this is continuous time or what you guys do it. So please pause the video and try to answer it. If you guys able to find out all the things, please post in the comment section that I able to got the answers. So okay, that will help me to check whether you are in phase with me or not. So we know that the second one's x of t is also continuous time signal, but here this one is n, so this is discrete frequency signal. So this x of n is already in discrete time signal. So this x of y, which is continuous frequency signal. So this is discrete time signal and this is discrete frequency signal. Okay. So here we have see all the things. So there is only two combinations, right? So four combination and all the possible ways we have linked it. So discrete to discrete, continuous to continuous, continuous to discrete. All the possibilities we have done. So we can convert from one domain signal to another domain signal. So this operation is called frequency domain conversion or any kind of conversion, maybe time domain conversion or frequency domain conversion, we named it. But here we have four operations, right? So we can't name everything with the same thing. So here each scientist and each individual have contributed for this type of conversion. So first conversion, the mathematical naming that we are giving is the continuous time Fourier transform. So here continuous time Fourier transform. So in the last class we discussed, right, this particularly have a good explanation, means it particularly has the entire it is one sub module. So the entire thing we are going to discuss. So how this can be converted from one form to another, how different operations can be possible, everything we discuss there. But in the entire signals and system courses we will be studying these four operations mainly. So that's what the main idea. So here, if we able to convert from the continuous time signal to discrete frequency signal, then this operation is called continuous time Fourier series. So this is Fourier transform, this is Fourier series. Each has different formulas, each has different procedure, each has each prerequisite to convert it. So here it will expect the signal to be in continuous time signal. Here it will be expected to be continuous in signal, but the output will be continuous here, but output will be discrete here. So those things I will discuss. I will teach you everything perfectly there. So for now, find out that these are the mathematical name that we have. So here it is already in discrete time signal. We are converting that into continuous frequency signal. This operation is called DTFT, means discrete time Fourier transform. So discrete time Fourier transform. So here discrete time to discrete. So this operation is called DTFS, means discrete time Fourier series. Okay. Apart from this, we have some more concepts also that I will explain detailedly. That is FFT, IFFT, DFT. That thing I will explain more clearly. Why we need that, why that cannot be done here. Those things I will let you know. But for now, please note the meaningful representation and meaningful conversion here. This will be helpful for you guys to focus on further lectures. So we have moving to the main concept, that is classification of signals. So we have plenty of classifications like odd signal, even conjugate, out conjugate, periodic, non-periodic, orthogonal, non-orthogonal, energy signal, power signal, causal, non-causal, anti-causal, bounded, unbounded, left side signal, right side signal, both sided signal. There is some 10 to 15 classifications are there, but we will be majorly going to study only 10 major classifications that are present in GATE syllabus, your college syllabus, everything. So that we will be focusing mainly. So first thing that what we are going to study is that classification of signal, continuous time signal and discrete time signal. You guys already know that I've already explained it enoughly. So let me even explain it more clearly. So first let us study continuous time signal. So let us take continuous signal. So first let me explain continuous signal. What I mean by continuous signal is that the amplitude value will be infinite. The range of the amplitude value will be infinite. Over the time period, we will have the infinite number of samples value we have. So the main thing is that continuous in amplitude. So continuous in amplitude. So amplitude part, we will have a continuous number of samples over the time. Okay, so this is mathematical. So this is math representation. But in mathematically, another one representation is also there. When limit x tends to 0 for the function f of x, which will be equal to f of a. So means this is finite sample. So it need to have some more number of samples, but that sample need to be finite number. That should not be infinite. That should not be a any kind of non-defined number. That need to be a finite number. So that is another one representation we can call it. So also one thing, it need to continuous in time. Here you can make it a also. Okay, because we are making this to f of a, right? So this sample need to be any sample. A can be any value, but that value need to be finite value. So that is what the thing. So thing is that both the vertical axis as well as horizontal axis need to be continuous there. So let me draw any example so that you guys can able to see it. So let me draw two signal. You guys let me know which one is continuous and which one is non-continuous. Actually, signal chain system is full of fun subject only, so we guys can learn it together. So I will be giving you more exercise, so you guys can solve it and post in the comment section, so that it be very interactive for you guys also, and for me also. When I see the comment section, I will be get motivated to teach more things. So please make a habit to reply in the comment sections. Okay, so here if you see, so this is one signal. So let me draw another one signals also. So over the same graph I am mentioning, so blue is one different signal, and then that red is another one different signal. Okay, don't confuse it. So this is t, this is x of t. Okay, here if you see, t is an independent variable. Okay, so t will be independent variable. So here if you see, the value is continuous in time. So here we can clearly state that. Let me take a green pen. So here if you write continuous in time, continuous in time, it need not to be necessary whether that signal need to be for the entire minus infinity and infinity. That is not necessary. That need to be the signal part which is present there, that need to be continuous in both the things. So that is for the signal. So here also if you see, the value is continuous in time. So the both the signals are continuous in time when the independent variable is t. So that is what one thing. So this is how the values will be there. So here if we take any kind of samples here up to here, this will be finite, and it is continuous in x-axis, is continuous in y-axis also. So this way we can call both the signals as a continuous time signal. So let me complete the discrete time signal, and I'll ask you few more questions so that you guys can able to answer it clearly. So I hope you guys have some idea on the continuous time signal. So let's take a discrete time signal. Okay, so discrete time signals are obtained from continuous time signal by process called uniform sampling. So CTS, which will be converted into discrete time signal with the help of the process called sampling, that I already said you. In previous class, I have detailedly said how the sampling process will work. That is nothing but a continuous on and off of the switch. So let me draw it here. So this is the timeline graph between the continuous time signal and discrete time signal. So here if you see, there will be a switch. This switch will continuously toggle from on to off. So this what will happen is that this continuously, this switch will go up and down. Means what will happen? The samples will be taken when switch is in on condition, when samples will not be there when switch is in off condition. So this is how we will be converting the continuous time signal into discrete time signal. So this is how. So here the t which will be converted into nts. The ts is a sampling interval. So when t which is equal to 0, then the ts which is taken there. When n is equal to 1, then will be ts. When n is equal to 2, then that will be 2ts. So like this way, those particular samples will be clubbed there. So fs which will be equal to 1 by ts. So this can be related like this, sampling. So this will be sampling frequency or sampling rate. In time domain it will be called as a sampling rate. So this will be sampling interval. So this will be sampling rate. Okay, so this is one very important question. So even in communication, we will be dealing more with the samplings. So let us take on real time scenario how the samplings will be done. So let me draw the case. So let me draw the two diagrams for that you guys can clearly able to understand things. So here let me take the continuous time signal here. Okay, and then here the sampled version of the signal, that will be discrete time signal. For simplicity, let me draw a unit step impulse. So for now you may not know what you mean by unit step. So once I have completed the classification of signal, you guys will know. So this is what unit step signal. So means the value will be only after t is in positive value. Before that value will be 0. Okay, so this is how the thing. So unit step signal, the amplitude will be a. So let me take the amplitude will be a, and this value which is equal to t, and this is x of t. So when we sample the frequency at a particular interval of time, so let me take a blue pen and draw a line. So these all are some particular intervals where we are going to sample the signals. So this is TS, this is 2TS, this is 3TS. Like this way we are going to sample the signals. So what will happen? What will be the output is that only those sampled version will be present in the output. So here if it is sampled at a t is equal to 0. So means value will be there. So it is sampled at t is equal to ts. So sample will be there. Sampled at t is equal to 2ts. So sample value will be there. And sample at t is equal to 3ts. So only the values will be present at this instance. So these amplitude values will be calculated. So rest all the things will not be there. So that is what the fundamental idea of samplings. Okay, I hope you guys able to get it right. So just a signal is passing, but where one engineer is sitting and just making the switch on and off, means what will happen whenever the switch is off, switch is on, the bulb will glow. Similar to that, whenever the switch is on, that particular sample will be clubbed. So this interval which will be named as TS, 2TS and 3TS as per the sampling frequency rate. So TS is the sampling interval. Okay, so this will be a, everything will be a here because it's an uniform step signal. So that's why we are getting this. So here the magnitude will be changed to NTS, and this will be changed to X of NTS. Okay, so this is how a continuous time signal can be obtained into discrete time signal. So this will be a discrete time signal, and this is a continuous time signal. Okay, so this is how guys, so this is what the general idea how we can take into picture of the things is. So here another one thing also we can take it. So we can convert this into, let me take a green pen and make it. So even some cases we only represent this with the x of n, means we will be divide the entire thing with the ts. So if we divide this by ts, then what will happen, only the numerical value will be there. So means this will be changed to x of n, this will be changed to ts, and this will be changed to 1, 2, 3. Okay, so ts value will be divided. Okay, so that is what the ultimate idea of this one. So now what will happen, n will be belong to an integer. So only integer part values, the value will be there for this signal, because we know that the only t greater than 0 the value is available. So okay, so this is how the graph can be converted to x of n versus n. So this is what the discrete time representation, DTS. So this is what the pure DTS. Okay, so this is how we have to take it. So one more thing, how mathematically we can convert, math conversion. So not only graphical conversion, we all everywhere we cannot be do this mathematical, right? So if the complex signal is there where we cannot draw the diagram, means we have to do the mathematical things. So on the time how we can convert the thing is that, so let me take x of t. So x of t which is equal to f of t, the t interval which is equal to a to b. Okay, so t value which is from a to b. So now what we have to do is that we have to convert this from continuous time signal to discrete time signal. Then what you have to do, the first step is that put t is equal to nts. Okay, so then what will happen, x of nts which is equal to f of nts. So this is how the value will be. Then the area of interval will be ts to b. Now what we have to do, we have to divide by t, put the value of ts. Now we have to put the value of ts, means simply we can divide by ts. So n, so here we may not know the exact sampling value, so that will be there. So if we divide by ts, this will be ts over the n, which will be b divided by ts. So this is how the representation will be varying. So let me take a one real time scenario so that you guys can understand the signal. So let me take the question. So x of t which is equal to sine 2000 pi t. So this is the signal where fs which is equal to 4 hertz. Okay, 4 hertz. Then find f of n, sorry, x of n. If you guys can solve this question, please pause the video and try to answer it. So let me solve it in the meantime. Okay, so first step what we have to do, we have to put that t is equal to nts, so which can be converted into nts which is equal to sine 2000 pi t. So here it is same. The thing will be like this. So now what we have to put is that we have to put the value of thing. So we know Fs which is equal to 4 means the Ts value which will be equal to 1 by 4. Okay. So here now we are going to convert this into NTS. So then what will happen? The thing is that here the T need to be changed to NTS. So then what will happen? So if we substitute the thing, then here will be N and the TS value which is equal to 1 by 4, that will be divided by 4. The simple. So if we divide the thing, then what will be the answer? The answer will be sin. So 500 pi n. So now what we have done is that we have obtained the x of n value. So this is how we have to do. So here we no need to apply it. So because here we are considering, so if we divide this by here, if you apply the value of TS here, then that is applied here. So that is why we are mentioning this directly. Here we should not mention that n by 4. This is wrong. Because here we should not do like, because this value is here. So this value is depend on this one only, right? So here we have substituted. So this one will also be get substituted. So like this way only we have to do. So don't confuse yourself, guys. So I'm giving you on homework. Please try to do this one. So next class I will solve this one. So x of t which is equal to 1 by 2 e power minus 0.5 t. Okay, so this is what the thing. So Fs which is equal to 10 hertz. So find the x of n. So please pause the video and try to answer it. In next class, I will solve this. So consider this as a homework. So in next class, I will be solving this. This is very simple. So just apply the same rule which I have done previously, so that you guys can able to get the answer. Okay guys, so I am leaving here. So we have completed the one classification, that is continuous time and discrete time signal. So next class we will be considering on the odd and even signal. Yep, and plenty of examples I will give, and also homework things I will give. So please stay tuned guys, like, share and subscribe channel, so that you guys will be able to understand it very clearly. Thank you guys, stay tuned.